Alright. Assalamualaikum and good afternoon. Okay, right. I think today going to be the last topic, which is belt, because I have mentioned before that for the bolt and welding, it's going to be a self-learning method, and that means I give the videos and you just proceed with the minor project. Right. I just start recording. Right. For the belt, actually we're going to use specific belt from the catalog. I just switch on the chat now. All right. Okay. This is the catalog. This is we get the value from catalog. Right. Okay. However, the first part going to be the general information on the belt selection. Okay, as I mentioned before that belt is the same as bearing, going to be selection. You don't have to do the design, but you have to select the belt. All right. Belt. Okay, belt very, I think very important. You can see a lot of belt in the power transmission over a long distance because of its ability to. Oh, sorry. Before we start, everybody can hear me. Sorry, I just start. Okay, everybody can hear me first of all.
Yes, I can hear
Yes.
you.
Okay,
Yes,
sorry.
betul.
Okay, sorry. I just start without. Okay, thank you. All right, this characteristic of the belt system. It's a long distance. You can see a lot of application of belt in the car. Timing belt is a part of belt and so many things. Conveyor is a belt as well. It's a flat belt and so on. It's basically it's going to be transfer of power. Okay, there are 4 types of belts. Flat belts is like a conveyor. It's just purely a flat, like a flat fabric, what I call it, fabric thing. That will be a certain thickness. Okay. This is going to be not upper limit, meaning that if, for example, a conveyor, okay, you can buy the belt as long as possible and you just fix at the end. It's no limit. Round bar as well is the same as the flat belt. It's no limit. Okay, but it's a limit. However, for the wheel belt and timing belt, they have a fixed, what I call it, length. Maybe you have a number of choice of length. Then you have to do calculation on that. Then the center distance is depend for the wheel belt and timing belt will be depend on the what belt you have selected. Okay. For these courses, we are just focused on the VBank only, the third one. Okay, this is the principle of VBank. For example, the easiest way to visualize how the belt work is you take a ruler, a rubber band, and try to what I call it, rotate. For example, the driver pull here, you try to this side, you try to rotate. That means you have rubber band in between. You just rotate this one, not going to happen. Okay, when you try to rotate this one, all right, what going to happen is that this is going to be very tight, very tight. On the other side, going to be a slight side. If you can see, it's a bit going down on the other side. Okay, this is going to be tight side. This is going to be a slight side. You can test it. That is will be the idea of bell. That means you rotate. How it works, I have mentioned this one. Okay, how this thing works. Okay, don't have the figures. Okay, right. How this thing works is that, for example, as this pulley, let's say this pulley are attached to uh, uh, at, this pulley attached to
Mana?
motors, to motors. The friction between the belt and the pulley, for example, will pull the belt. For example, like this one, it will pull the belt on this side, and that's called this will be on the tight side. Okay. Okay, this will be at the same time when this is pulled, what's going to happen? This one, the driven pulley will rotate. That's the main idea. That means it's rely on the friction here, friction around the belt. That's the reason why you see, for example, let's say in the morning, you will hear certain thing. You will hear that sound of, when you switch on the aircon, there's a sound of very sharp noise. Maybe there are a lot of, for example, in the pulley, there is maybe a few oil that splash on the pulley that cause the belt to slippage. That you can get sound. You hear that a lot when early in the morning, because the belt, maybe there's a lot of oil slippage, and that cause the slippage between the belt and the pulley. Because it totally work on friction. Okay, that means this work on friction, and this will after when this try to pull this one, this cause to be this one to be rotate. Right, that will be how it works. Okay, this is the basic equation. Okay, F1 going to be in this case going to be the tension side. F2 going to be the slack side, the tension of the belt. FC then going to be centrifugal force. FC going to centrifugal force. Okay, it's not equal, but this going to be the limit, and this going to be the limit. That means this going to be limit here. What it means here that E F theta, the F is going to be the coefficient of friction between the pulley and the belt. Okay, theta going to be the wrap angle here. For example, what is the wrap angle? This is going to be in, let's say I assume going to be like that. There's going to wrap angle here in radian. This is theta going to be wrap angle in radian. What it means here is that, okay, what it means here that the it rely on the friction, and it rely on the wrap angle. And how much, that means the larger the wrap angle going to be, that means the higher the value here. Okay, why is it's not equal? Meaning that this is the limit. That's where the point where, for example, this value is very large, right? Maybe, for example, let's say you have motor, you put a larger power motor here. All right, what's going to happen? The pulley going to be rotate faster than it should be. This value to be larger. That's called, when that is happen, what's going to happen is this value. Meaning that there will be a slippage. It won't happen that way. That means this value must be smaller of that value. If this value is larger, then the value of here is larger, and this value is larger, then it will have to have slippage. It's going to be slippage. That means the belt going to be rotate, the pulley going to be rotate without pulling the belt. All right, that's going to be a slippage. That is very important. Meaning that what you should do is that you have to make sure the motors you install at the driver, make sure it's going to be smaller power than this value. That's very, very important. If you put larger power, going to happen, going to be slippage. Basically, it's just the pulley going to rotate, and the belt doesn't have anything. Very important, because when there is slippage, the friction is turning from static friction, from static, which is higher, static friction, to kinetic. There is a static coefficient of friction, okay, to kinetic, kinetic static coefficient, which is what we mean that the value of static is going to be higher. Is it right? That means why you have to have that when it rotate, it's going to rotate forever, because this will be higher, because you don't go beyond this value. When you go beyond value, the coefficient will be a lot lower. That means this value going to be lower, because it's changing from static coefficient to kinetic. That's the basic idea. That means the ratio of the tangent side and the slack side, and the ratio of the tight side and the slack side. Okay. Sometimes, for example, we have a tensioner. Okay, make smaller here. Why we need tensioner here? It's used to increase the wrap angle. Remember the formula here? Wrap angle is in that value. That means by increasing the wrap angle, the what you call it, it's going to be higher value here. That means it's going to be higher value. That means you can have a higher driver motors, and that's the idea of having a tensioner here. However, when you have a tensioner here, you will reduce the life of the belt. That is the disadvantage. That means there's two things. You can have a that when you have this increased wrap angle, however, reduce the life of the belt. Okay, what we're going to do now, okay, we're going to, okay, I think that's about the belt, basically, is you should understand this formula, all right? This formula, what it means. Actually, is the y is not equal because that is the limit. I mean, that means you have to, on the other side is your, you cannot go beyond this limit. If that beyond that limit, that will be a slippage. That's the main idea. Apart from, we don't have equal, but we have a smaller or equal. Then the best will be equal. Okay, but it should be smaller or equal. All right, that's one thing. All right. Okay, with that in mind, with that in mind, we're going to solve a problem here. At the same time, we're going to uh, to uh, to solve based on the manuals. Okay, let me explain the manual you have. I think there's a lot of thing in the e-learning. There's a first how the belt constructed. That's the first one. Okay. The first one is going to be wrap belt. That means all the belt here going to be wrapped with a cover fabric. Unlike this one, this is going to be, there's no wrap belt. However, the top will be on the fabric and on the side. The difference between this one and this one, all this area is going to be, can attach to the pulley. Because this one can attach to a pulley and this one as well. However, this one only on the side here. That means the friction is only limited to the side of the belt. Unlike here, you can have the side, left and right, and the bottom. You will see that this have a different value. That means the aspect going to be, this going to be higher power because it's more friction. Imagine in the basic equation here, you have a friction here, right? That means larger area, that means larger friction, you can have a what I call it, larger value. That means this will be have a large, can transfer more power. Okay, as you can see here, there's so many. This example, the one that we call it. The wrap will be A, B, C, D, E. This is how do we classify the belt. Type A, Type B, Type C, Type E. Within the A, okay, the other one here, all right, the belt that will be touching the pulley on just on the side with EX, BX, CX. There's no D and EX. Only A, BX, and BX. This according to this type of belt. Okay, there's more belt. There's a 3V. The shape is going to be V, 3VX, and so on. There's you can talk about more belt here, and there's a more example type of belt. However, we just focus in these two. These two type of belt here for this session, for this exercise. Right, that is the first one. The second one is the all formula related to the belt. Okay, these formulas is just for you to, is for example, to refer. All right. Okay. All the angles, all the wrap angle will be in, all the angle will be in red. This one will be, double check whether going to be in radian or in degree. You have to double check. This one will be in degree. Angles, be careful. You check whether in degree or radian. Some of the question in the book will be in radian. You have double check the value. This will be the all the formulas. That the second you have. This is going to be the step to calculate how to select the belt. Step 1, step 2, step. There's so many steps here. There's step 1, step 2, step 3, 4, 5, 6. and 7 finally. That's 7 step. You just follow the step. All right. I think this is going to be the a bit unlike the first step. Then going to be you have to tell your free body diagram and so on. This you have to follow like the same like your bearing. The bearing the difficult part is your free body diagram, right? But selection bearing going to be just follow the step the same as go for here. The the third slide will be A1, A3 will be the belt calculation. This is going to be the step. Okay, that's the V4 is a power belt power. Okay, based on A, based on B. Okay, there's a C type. Remember I mentioned the A, B, C, D, and E type. D, okay, D, and so on. This is the power. And oh, this is not power. This is the length. Sorry, this is the length. And this is what I mentioned just now. This is the length. For example, let's say, okay, we have A64. Okay, that means A64. We're going to choose this value. For example, 64. Where is 64? Okay, this one 64. All right. Okay, the length of the LA going to be there's a LA here. I think the pitch going to be where is the higher one. Datum line going to be the pitch. Okay, LA I think on the top here. Either one, double check. Outer length, that means LA. That means if you have that belt with A64, that means the length of the outer part going to be 66 inch, and the pitch may be roughly here. That pitch going to be 65.3. That's what it means. That means, okay, that's what it means here. Why it say here that in the case of what is limited? We limit because of we cannot have any value. For example, we have a wheel belt here. Let's say we choose this wheel belt. Then we have all the configuration of driver, pulley, and turn to distance must follow this equation. We cannot have, okay, let's say I can have this one. That means all the configuration of the larger pulley, smaller pulley, center to center distance, we rely on this information. That's what it means is limited here. Unlike the flat and the wheel belt, you can have any type of what length you want to have. You just wrap the pulley and you just combine, you just join the belt. That's it for the flat and round. That's why there's no upper limit here. Right, that is the fourth what call it? The fourth I think I forgot to pick the fifth one. Right, I have the fifth one that we put here. Right, the fifth going to be I think some of the configuration. Remember I mentioned to you AX and this AX. This is configuration here. Maybe you need the weight and the Y. In the formula here, you can refer to this. I think this one you need the weight here. All right. Tension side, W weight, weight, W belt weight per unit kilogram. Then you have to refer this one. This is going to be the property of the belt. Maybe it's required when you do when you need to use the formulas. And finally, it's going to be A6 going to be your power rating of the belt. That means, for example, let's say I use let's say I have A type of belt. Okay, my small pulley going to be, let's say, 3 inches. That means I cannot have smaller than that. I might have 3 inches. That's one thing that you bear in mind. Let's say my belt is A. I'm going to use 2.5 inches small pulley. You cannot do that because this is going to be the minimum. All right, 3 up to 7. All right. Okay, what is the RPM as well? Imagine there's the lowest. They have the value this year. There's no value below 700 RPM. Why? Because the belt a bit different from it's a bit unique on power transmission because it is not good at a lower speed a rotation speed because it will vibrate. For example, let's say you have A belt type, minimum will be 700. If your design goes 600, let's say it will work, but it not effective. Okay, what I mean. Bear in mind, the belt they have limit. Certain speed, for example, in your project, you have faster speed, lower speed, and the lowest one. Maybe the belt cannot be used on the lowest one because maybe the speed maybe just 10 RPM. It doesn't work that way. It must have certain mean it will go at the near to the motors. That will be the in this case going to be there's 100 here. 100. But it's a certain value cannot work. Let's say below 100 cannot work. That's what it means. 100, 200, 300, 400 and so on. That will be the belt. Cannot have a limit on the speed. Okay, that will be A6. Okay, what I want to do now, what I'm going to do now, you have to go through this A1, A2, you have the note, A3, A4, A5, A6. I give you up to 230 to get familiarized with you because after this, we're going to refer to this one, to type 3, we're just going to solve this problem. All right. Okay, right now I up to 330, what I'm going to do that, you just get yourself familiar what is A1, what is A2, A3, A4, A5, and A6. Okay, 330, just to go through the belt, the back catalog. Okay, right? 330. Okay, I think by this time you should aware of the 6 catalog. You should know where to look for. Okay, the basic properties of catalog will be A1. The formulas, maybe require the formulas. The step will be in step 3. The length of the belt will be A4. The belt's other properties will be A5, and power rating going to be A6. Okay, you should get the idea of all the type of catalog here. There's a 1, 2, 3, 4, 5, 6. Okay, remember that thing, eh? Right. We start with our example now. Okay, let's say we have this configuration here. We have the output input, okay. Type of driven, that means type of driven will be crusher. Maybe this is going to be crusher here. That means the output here going to be a crusher. Motor capacity going to be 200 pound-inch at 500 RPM, which is the maximum power of the motor here is output here, actually the output, the maximum output here going to be possible lower 300% of power rated, rated power of the motors. Running is 10 hours per day. Speed ratio going to be 3 to 1, that means the diameter here 3 to 1. Okay. Environment going to be dusty environment exposed to rain, meaning that they have a culture. Maybe you put in they're going to be dusty and exposed to rain. Okay, what you're going to do that when you have all this information, apart from here, based on the design work conditions stated in table Q2 and figure Q2, determine the belt type, belt length, center to center distance, the number of belt, and the minimum static tension and the tight tension. Right. Okay. We start with number 3 first, because this is going to be step. Okay. Set the condition that require. Type of machine is a crusher. That means you have to crush. That means I have to put here. Right. Power is going to be torque and RPM. This is power motor going to be 2000 pound-inch and 500 RPM. All right. It's going to be 2000 pound-inch alias 500 RPM. 500 RPM. 10 in a single day. I think is it in the second 10 hours? This is very required for to use the catalog. Is it 10 hours? Is not, Yeah, 10 hours per day. Speed, small speed ratio. All right. Driver going to be 500. Is it right? This is going to be 500. Small pulley speed going to be 500 RPM. Okay, speed ratio going to be 1/3. Is it right? It's going to be reduced by 1/3. That means it's going to be reduced by 1 divided by speed ratio going to be, let's check here. Larger pulley datum diameter over small pulley datum diameter, meaning that, okay, because it's going to be reduced, the larger going to be larger, they're going to be large, that means it's going to be equal to 3. Careful, because the speed reducer, the larger pulley going to be the by reduced by 3, that means it's going to be 3 here, that means going to be speed ratio 3. Okay. Interim center to center distance, all right, is it given here roughly estimated U1 initially going to be 80 inches. Going to be 80 inches here. 80 inches. Right. Special use, what going to be? There's two, water and is it dusty? There are two environment here, water and dusty environment. Is it right? There's a water, subject to rain, exposed to rain and dusty environment. That is going to be water and dusty. That's the first step. Okay, this the step that set condition required for the design work. This is going to be the initial design. Okay, I think this is going to be what I'm going to do is just to take the information from the question on the environment or whatever you have. Okay, right now what we're going to do next is that step number 2, set the design power. How to calculate service factor? First of all, Ks equals service factor. K0 is the service correction factor, table 2.1. Ki, idle correction factors, table 2.2. Ke is the correction environment correction factor. Okay, let's check what is the K0. Okay, K0 is going to be, what is going to be? Output. Okay, you look for what they're going to be. All right. Type of motors is going to be, maximum power is going to be less or larger than the rated value, 300%, and the running hours. That will be the K0. Okay. Ki is going to be the position of the idler here. All right. Okay. Remember, you have to know where the belt is. In this case, where you rotate here, this driver, you should know where is going to be the tight and the slack, where the position of the idler. Based on that, you can have the AI. And finally, going to be environment, dusty and oil and so on. All right. I think this is going to be a bit straightforward. I give you roughly 240 for this one. Can you do this? 240? All right. 2 of 2 or make 240, 41 or 42. All right. 242. The end. Just to get the value of service factor here. Okay, right? KS, K0, we start with K0. Alright, it's going to be crusher. Okay, going to be here. That's going to belong to here. Alright. It's going to be the motor capacity going to be maximum power going to be less than 300%. I mean less than 300% here. And the work hour going to be 10 hours, 8 to 12. This is going to be 10 hours. This is going to be the 10 hours going to be here. That means equal to 1.3. Right? 1.3. Alright. KI, idler. Alright. For idler, we have to make sure that how this thing works. For example, let's say if this thing rotate here, what's going to happen here? This going to be will be on the tight slide, is it? This is on the tight side, and on the top here going to be on the slack side. If you don't, I have an idea. You just make sure you have you take a rubber band and try to rotate your finger here. This is going to be tight, and the other one going to be a bit down. That means this is going to be on the tight slide. I move it here. And this one will be on the slack side. Okay, that means your idler will be located, will be positioned at the slack side. Okay, your idler going to be positioned at the outside. It's not inside because this is going to be outside of the slack side. Outside of the slack side, outside 0.1. That means this is going to be 0.1 here. Okay, it's going to be 0.1. Environment, there's two environment here. You have oil and water splashing as well dusty. That means 0.2. Add 0.2 is going to be 0.4. This is going to be 0.2. Another one will be 0.2. There's two environment. That means 1.3 plus 0.1, 1.4 is going to be the surface factor equal to 1.8. That means you have to design of power 80% higher than the design one. That's what it means here. That means 80%. 1.3, 1.4 is 0.2, and another 0.2 going to be 1.8. Okay, I think other than this is fine. This is very straightforward. Okay, this is straightforward. This is straightforward, except that if there are two more lists, you just add the 0.2 for each list. For only the KI, you have to understand where is the tight slide and where is the slack side. If you don't understand that, what you should do is that you take a belt, you take a rubber band, try to rotate the same environment. What's going to happen? This is going to be very tight. This one going to be a bit go down here. Is it right? That means this is going to be a slack side and a tight side. Meaning that the other going to be on the slack side outside. That's what it means here. It's going to be slack side outside. Slack side and outside 0.1. All right. I think the answer you need here is that the KI. Other than you just based on your information, you just pick the value. All right. Any question so far on the KS? Any question on the KS service factor? All right. Yeah, proceed. Okay. We just follow the step. Okay. Now we have to calculate the power. Okay. You see that if the power in kilowatt convert to horsepower. All right. For this one, the transmission power going to be the TQ, all right, going to be torque in pound inch, all right, and the shaft speed divided by this value. In our case, it's going to be what is the 2,000, okay, time 500 RPM divided by 630 63025. The value going to be in horsepower. Okay, let me have my calculator here. That is going to be the required horsepower, 2,000 pound each, The unit is in pound each. Our going to be in pound each here. All right, at 500 times 500 RPM in RPM here, divided by 63025. That means 15.866, 15.87. All right, 87 horsepower. That means that is the required power. Okay, then the design going to be, as mentioned before that, the safety factor will be, maybe we have to design 80%. That means safety factor going to be 80%. It's going to be time 1.8, going to be 28.56 horsepower. That we're going to choose, and the design going to be 2856 because the safety factor is going to be 80%. All right, 26.58. That will be the design power. Right. Then I think this is straightforward as well. This plug the value to the information you have, and insert the value to the power to the equation. Except for anything that in kilowatt, convert to horsepower first. Okay, done. Step 1, step 2, step 3 done. Except what you need to have is that understanding is the slack and this one. Other than that, is just plug the formula to the whatever you have in the here. Whatever you have in here, plug the power into the equation, except for Ki, and understand where is the slack and where is the tight side. Okay, that will be step 1 and step 2. I think it's very going to be straightforward. Right, now we go for step 3, which is, okay, we have the power here. What we should do, we choose the type of belt. Meaning, this go what we mean here, that for example, E-belt, okay, for example, let's say I have, 500 horsepower here, okay, it runs at 200 RPM here. And that's what I mean here, then I can choose E type of belt. If we run at 950, I have to choose D type of belt. If we run at another value of 1,450 RPM, if the small pulley, that will be at a C type of belt. Then if you run at 28250, that will be B type. And finally, it's run more higher than maybe value of, let's say 4,000, it will be A type of belt. This is what we're going to do, and that is going to choose type of belt. Okay. Design power in our case going to be 28.56. Okay, I just draw a line here. 28.20, 30, they're going to be in lock area, 20 roughly. Right, the RPM is going to be in 500, is it right? Our RPM is going to be 500, the smaller pulley. I think this is 20, 25, 28, I think we should get a bit here. Right, 29, all right, that will be C type. Let me check whether my example using the C type. Okay, right. That's correct, and the same thing. Right? Because of 28, it won't be, I choose that value going to be 25. 28 here, what you're going to choose is going to be the C type here. That means our belt going to be using a C type belt here. That means here going to be step number 3. We're going to choose C type belt. Okay, this very important as well, because when you choose the wrong, for example, let's say like just now, I make the line is not roughly here, then it become B or C. This is not 28, right? 28.8 going to be roughly 29. It should be a bit closer to 30. That means uh, you may see, made a bit of C. For example, the other mistake that maybe come up with that, for example, let's say you make mistake in calculating the power here, maybe the KS. Then you are choosing the different type of belt. For example, maybe choosing type B or type D. That maybe cost you the mistake from now on to the onward. That means all the steps here are going to be wrong because you're going to select different type of belt. You're going to choose because the different type of belt have different length and so on. That's very important. That means you have to be careful on this one. Okay, what is the value? What is the on this belt? This is going to be, in this case, going to be C. If you make mistake in this one, the more mistake will be coming up on the step 4, step 5, and step 6 and 7. All right, be careful. This is going to be number step C. Very important. All right. Any questions so far? I think it's going to be straightforward. Okay. That we choose the power based on the design power in horsepower and the RPM of the smaller pulley. All right, they're going to be C. Okay, right now, okay, after you got the C value here, what you should do now is that, okay, this is the thing that you should have. In the case of C, you can have CX or C. Okay, doesn't matter. You can have CX or C. Let's say we choose C here. Now you start to design your pulley. Is right. All right. You have C9. That means the larger one going to be ratio, right? The SR going to be from here. It is ratio 3. Remember the calculation the first time here, the speed ratio here, 3. That means what you should have here is going to be, this is going to be equal to smaller pulley 9 times 3 because we're going to reduce by 3 speed ratio. It's going to be 27 inch. Okay, what we're going to do now is that this is going to be your initial design. I don't have the drawing here. Okay. Okay, hold on. Right? Right. What I should do now is this one, this calculation. This is going to be 27. What we have here, what we're going to have here, this is going to be 9 inches. This is going to be 27 inches. That is going to be starting our belt system, our pulley system going to be take shape. We have the 9 inches here, 27 inches, then we have 18 inches. That means we have to look the what is going to be the type of belt here. That means which belt we want to choose from here. You know, we go, this is the one, which is the type belt. We're going to choose C. Which belt we want to choose? The C type, so many, the 40 to up to 107. Which belt we want to choose? That means it's rely on the, okay, what the question we have in our calculation here? Okay, we rely on the LD here, which is the Datton length here. Meaning that we choose our number 4 here based on this value. You're right. Then if you got the value, then we can choose the belt code. Okay, that's what you should do now. Okay. For example, let's say we have this one is C going to be, in our case, we know the value of C. The center distance is predetermined. That means we're going to use type C here, formula number C here. I think it's basically going to be the same formula. This going to be the C value is going to be estimated interim center a bit careful, because the formula here is a bit different. If you choose this formula a bit different here. Right, this is going to be the, if you know the predetermined center to center distance, you choose equation number 3. Okay, right. The C is going to be, right, center to center distance, which is equal to 18 inches. All right. This C going to be equal to 18 inches. D going to be the larger D, smaller D going to be 27 inches. All right, the smaller D going to be 9 inches. All right, can somebody calculate what is the value of LD prime here? What is the value of the LD going to be datum length of the belt? Can somebody calculate and write the answer in the chat? But insert the value there. Okay, see 18 inches. 27, there's 9, okay. 4 over C, what is the value here? Please, somebody. 97.05, right? 97.05. All right. Inch, eh? All right. Let me check which number 4, right? Okay, 97.05. We can choose. You're right. It's up to your choice. If you choose 96.9, 96.9, because remember, we cannot if we maintain this value, oh sorry, where is the marker? If you maintain the diameter center 80 inches, larger 27.9 inches, we need 97.05 the length. However, there is no such 97.05. We can have 96.9 or 97.9. If we choose 96.9, what's going to happen? The center to center going to be closer. Is it right? Because 97.02 is going to be, 05 going to be larger. That means if you choose smaller of this value, what going to happen? The C going to be less than 18. All right, that's the choice you have. If, for example, the question that, okay, the maximum value going to be 18, that means the choice going to be in C94, right? If the other one, if the question say that, okay, the minimum value going to be C18, that means you can have larger one. The choice you have going to be 97.9. It depends on the question. And let me check. Do I have any question here? Don't have any question. Okay, let me assume going to be we choose, that means we can have larger C, is it right? If we choose 97.9 here, that means we cannot have 18. We should have 18 and larger. All right, that means we're going to choose here, going to be, all right, based on this one, we're going to choose C90 what? C95, all right, C95, right? C95 with the LD of 97.9. 97.9. This from table A4. And remember, you should remember the table, which table? 97, oh, I guess 97.9, 97.9. Right, inch, eh? That will be the LD here, 97.9. Okay, this C95. Okay, meaning that, all right, we cannot have 18, right? Right? We cannot have this fine. If you want to maintain this is fine. What should you do now? Then we should recalculate back the C. Is it right? Because we cannot have 18. That means because we are using, if we maintain 18, this value of 97.05. However, we're using the larger LD, meaning that we go back here, calculate the new C. You should get the value here should be 18 and above. You should get Below 18, that means something wrong with your calculation. Is it right? That's the idea, because we are using the larger LD. All right. Can you calculate for me, please? What is the value of the new C here? That means the C here is not right. We should have a new C. Center to center distance. Okay, calculate for me, please, by the new value of C. B equal to this one, the value of B will equal to this value. 2LD, the length is 97. Not the LD going to be 97.9. Be careful, it's not 97.5. 0.5 going to be 97.9 because we are changing this value. Right? Can you calculate for me, please? Okay, somebody please. What is the value? Should get 18 and above. Okay, if you got below 18, get something wrong with your calculation. Okay, somebody, can you get calculation for me, please, calculators? Is LD 2LD minus pi, minus pi D plus larger D minus plus smaller D. Okay, somebody please, can get the value for me, please? Anybody? Right on the chat. 18 point, it's going to be correct. 18.48, because we are going to be larger one. That means the new C is going to be, that is how you estimate the value. That means the new C is going to be 18.49. This is going to be the configuration of your pulley system. Okay, you're going to have D, smaller pulley 9 inches, larger pulley 27. Then the new C is going to be 18.49, center to center distance 18.4. Okay, roughly, double check, maybe 6 or 4. Whatever is correct, you have the larger value. Let me check mine. What do I have get here? Mine is 18.48. 4849. This is my calculation here. Right? 18.48 or 49. That's correct. That means this will to be the value of the new C. This is going to be, that means up to step number 5, what you're going to, at the end of the day, what you're going to do is that you can get a configuration of the pulley system. Of the pulley system. That what you're going to get. What is the diameter of the, what is going to be the diameter here? What going to be the diameter of larger here? What is the value here? Okay, this is going to be 18, going to be your initial proposed, but you cannot have that because the length here is going to be fixed. If the question that minimum for 18, you choose the larger one. If the question asks you maximum of 18, that means you have to choose the smaller one because the answer should be lower, 17 or 16 and below. And that's the idea. That will be the idea. Meaning that up to step number 5, you will have your configuration of smaller pulley, larger pulley, and your belt type. Your belt type is going to be C95 and the new center to center distance. This is all the configuration. 1, 2, 3, and the belt type. They're going to be the configuration of the pulley system. That means that will be the first step. That means you have the small pulley, larger pulley, and center to center with the type of belt. Okay. Any questions so far up to here? Because we're going to, after this, we're going to calculate the number of belt. I explain after set number 6 and 7. I think 7 is done. That means we have two more steps left. Okay. Any questions so far? Up to step number 5, we just calculate we just have the initial design of the belt system. Small pulley, larger pulley, the new system, the new center to center distance, as well as the type of belt. All right. Any question so far? Okay, I think that's okay. I think compared to your previous type of question, I think this is going to be a bit easier. Right. Now we go for step number 6. Okay. In belt, in V belt, there's certain power. For example, let's say I take, we want to have the value of 28. Is it right? What is the value of our power? Let's say we have 28.56. Okay. Let's say I have a C type of belt that have only 10, can take one type of belt of C type can take only 10 horsepower. That means we should have 3 type C, right? That means we should have, let's say we choose, that means we need to have 3 belts. Is it right? Because the first one will take the 10, 10, and another one 8.56 going to be 10. That means we're going to have 3 belts. That means that's what it means here. I say the type of C going to be 10 horsepower. You need to have C, meaning that each belt can carry less than 10 horsepower. That's what it means. That means, okay, for belt type here, the power here, this is going to be the specific power rating at certain speed, at certain, what I call it, certain speed here, certain diameter pulley, small pulley. Meaning that at that we want to be 2.85. For example, if I have 5, we need to have 2 belts. If I have 10, we need to have 4 belts. 2.8, 2.8, 2.8, 10. Yeah. Is it right? 10 divided by 2.8. Okay. It's like say we have 10. 10. Our design 10. That means we're going to be this 10 divided by 2.8 divided by 2. I want to see 2.83. But the idea is that you need to round it off to the next round number. That will be the total number of belt. All right. 10 divided by 2.83 going to be 3.55. 3.53. Then you round it off. Not try round it off. You just go to the next round number. For belt. Next round number. Not round it off. If you round it off, 3.1, you want to go to 3, right? You need to have 4. Okay. Next round number. That means the next larger round number. That will be the belt number. That's the idea of having the number, how many belt you have. Okay. That will be the idea of step number 6. Okay. After you have the configuration, the next step is how many belt you want to use. Okay. Let me have the formula here. Okay. I just explain and you should do the rest. All right. Okay. H design, I think we calculate that. That will be 28.56. That is 28.56. This is going to be 28.56 horsepower. Okay. AC going to be the corrected power rating for per belt. Okay. Which is equal to SS, SA. Okay. What is SS? The basic power rating. Okay. What is the additional power rating is going to be in here. For example, like here. This is SS. Okay. You actually see, we are using C. Alright. This is going to be SS. This is going to be SA. Okay. Because there's additional power rating because of the different speed ratio. That's the main idea. This SS. this is going to be your SS here. This is going to be SS. This is going to be HA due to the speed ratio. All right, that will be the main idea here. HA. KC. KC, what is KC? Is going to be power rating correction factor with K theta over C and refer to this value. Is it this? That's KL, this value. If D, remember yours is going to be 27 minus 9, is it right? Divided by the new C, 18.549. They're going to be 18.49. Okay, 18.49. Okay, in between you have to interpolate. Let's say you have value of 0.32. That means you have to interpolate. You get the value of K theta here. This is the value that we are interested in. If you have 3.32, for example, 3.4, you need to do the interpolation here. You need to interpolate. Let's say, for example, I look for value of, the value going to be 0.32. You need to do interpolation. Okay, that will be the K theta here. KL is rely on your LD. Which your LD going to be 97.9. 97.9 type C. That's it. 0.91. 97.9 type C. Then you get the value here. You get this value, you get that value, you get that value. This one, the same. You have to interpolate in the case, because the selection is based on power rating number 4, is it right? Number 6, Okay, let's say type C. Type C. Okay, what you have? 9 inches. RPM going to be 500. All right, that means you have the value. What is the ratio? Larger than 3. Then you have that value. If, for example, your speed going to be 320, for example, like here, let's say I want to use 320 here, right? 320, and your diameter pulley is on 9.2, that means you have to double interpolate, or vertical and horizontal. That means you have to look the point here. All right? At the point value here, first of all, value here, then interpolate again, 3 times interpolation. If, for example, you have the value here. But in your case, going to be 900, 500, no need interpolation, 3, no need interpolation, you get the value. Insert to the equation here. Then round it off to the round number. You got the value here, SC, HD, round it off to the next larger, then you get the number of belt with the type of belt will be C95. How many belt do you want to use? All right, I think I can give you around 5 minutes. Is okay? 322. Using these formulas to proceed with the finding the number of belts. 322 or 23. Make 23. Make 25. That's fine. Not to worry. All right. 3:25 p.m. Number of belt. Sorry, for the designation that means 95. This is C95, that means 95. It's not the length, it's going to be the what the C95 going to be 95 here. It means going to be 0.9. Then that's my mistake. It's not the length. It's going to be the what value here. Just go through the. Okay, we start with K theta first. K D over D minus C 27. 18.4, you got 0.974. That means you have to do the interpolation here. We have to interpolation here. We get K theta going to be 828. Okay. I think let me double check. This one doesn't matter. It should be designated length. Let me check here. What the length here? This is datum length. Designated length going to be this one. I think it should be 0.9 here. This is going to be, not to worry, this is going to be 0.9. That means the number, designated numbers of the length, we are designated the length number is going to be 0.95 here. And that is going to be the designated, but the actual length going to be this length, if we follow the datum length, right? Designated length going to be this number, 95. That means for that, on that, and 95. Where is it now? Okay, where is, okay, let me down here on the D, the calculation here. 95 going to be 0.9, there is going 0.9 here. Okay, 0.9. Okay, KC equal to KL K theta. Okay, make correction here. I think at the end of the day, it will affect the number. It won't affect that much the number. That correction here. Okay, for S, the 9 500, you get 7.6 horsepower, and ratio of 3 SA 0.74. That means you will get 0.76, 0.573, roughly 0.628. Then the number will be 4.5. Then you get the next one number going to be 5. That means what you need to have here going to be, you need to have 5 C95 belt. 5 C95 belt. That means you have to have 5 in order to have to carry the load of 28 point whatever value here we got here, 28.56. Okay, that will be 5. All right. Okay, that's it done. All right, then we got that value. Okay, we got the 5 here. I think for the design of the belt is fine. It means the next step going to be the installation. How we going to install? Because of the belt. Remember, the belt going to be fixed. This going to be fixed distance. All right. That means one, the pulley need to be moved. Because there's a larger pulley, small pulley. Because you want to install that one. When I mean, you have to install, because the value here at the end of the day, this is going to be when you're running. The center distance going to be 18.49. Okay. However, when you try to install the pulley here, that means the pulley must be movable. Otherwise, it doesn't work. If going to be fixed, it doesn't work. Because the pulley is going to be the belt going to be fixed. Fixed length. That means, for example, you want to install that one, what you should do that you make the center distance closer here, insert the belt. After that, you make it to the configuration. Okay, what you have here, what is the length here? The length, installation allowance, take up allowance based on the C type. All right. up to 95, 85 include 112, that means C-type 1.5. That will be the installation allowance, this one, this will be 1.5 inch. Alright, that mean the slot, that mean the smallest distance is going to be the C minus this value. Remember the center distance going to be 18.49. That means minus that one, that will be the smallest center distance, and the take up value going to be 95, going to be 2.5 here. It's going to be 2.5 inch. That means you need to have slot roughly 4 inch. That means the small plate will move around 4 inch. Okay, this will be the configuration you need to have. That means the first configuration going to be you choose the belt here instead number 5. All right, that's the first configuration here. This is going to be your first configuration. The first, what is the smaller pulley, what is the larger pulley, what is the type of belt, and what is the center to center distance. That's the first configuration. The second configuration is how many belt you want to use based on the selected belt here. The third configuration is going to be how you're going to have how you want to make the one the pulley to be movable. What is the largest slot, and then what the smallest distance and the largest slot. What is the allowable tolerance in order to have the smaller pulley to move. That will be the 3 configuration you need to have based on the 7 steps that you have to follow. All right, I give you 2 minutes. Any questions so far? That will be configuration. Okay. I think. Okay. Okay. Let's just share again. The biggest mistake is, for example, you make a wrong belt type. You make a wrong, for example, let's say this type. Maybe you make mistake in calculation of the power. Then all the calculation after that will be error. Be careful on that. After that, if you got the type right, then it will be straightforward. All right. Okay, I give you go through for 2 minutes. Just go through any question, any inquiry, any problem with the method, procedure, or whatever. Except that the designated length will be the belt designated number, C95. It's not the LD. LD is the datum length. Any question? Okay, look, I give two minutes to go
Doctor,
through.
I
Yes.
have one question. Why do we use the designated length of 95?
Because of we choose C95. The destination is 95. I think the information that okay, you said here destination, right? That means we are, what is 95 here? Didn't see 95 here. It's not the length, because C95 there's 2 information here. In the example I made mistake. Okay, in the C95 here, there's 2 information here. The information of datum length. Okay, this is destination length. C95. Okay.
Okay, Doctor.
Okay, but if the difference is not that large, at the end of the day, the value going to be the same, mostly the same, because we're going to round it off to the next round number, except for maybe if you, for example, to have the value of 9.99, and maybe you might go jump to 0.01, that may be a bit different. Okay, right? Is the designated length going to be this one, this number? All right, because the length here is going to be datum length. Okay, any more question?
I have one more, Doctor.
Okay, go ahead.
All right. How can I see the calculation for HC? How we obtain HC?
The additional. All right. The HC is from power. All right. HA or HC? SS. There's 2 value here. HC. Okay. HC, you just follow this equation. Write this equation. SS, SA, KC. Just follow this one. Alright, you start with KL, K theta, you're going to be, you have to reverse the process. Calculate KL, K theta, KC, SS, SA, you got HC, that means the power rated per belt. That's what it means. And is it right? AC going to be corrected power rated per belt. That means that power can be carried by the belt, by one single belt. Okay? Right.
Okay.
Just follow this. Okay, that's what it means. That means this is the power. Let's say you have 28. The power of belt maybe let's say 5. That means you need to have you divide that thing and you round it off to the right next round number. That's what it means. That actually is going to be the how much power the one belt can carry. Okay. Any more question? All right. Okay, we discussed this one. We share the final one going to be the how do you want to do the report? How we going to? Oh, sorry, this one. Okay, for the project, remember your projects, right? You have 3% or 2%, right? You can choose this one, Replace the first pair of gear. Actually, is the highest speed, meaning that the first pair. Motor, the first pair. Okay, replace that the first pair of gear. Did I mentioned did I mention to you when you have smaller gear, where the problem? Maybe you can use a belt. Okay. First pair for sure because the RPM going to be very high. Okay. The first person going to be minimum center to center distance of 80 inches. Minimum, Whatever you choose the smaller one. The second person, okay, among you, you have to choose, okay, I will do the first one. Okay, the second person will do, okay, maximum distance of center distance 23, right? And finally, minimum center to center distance going to be 20. Okay, if 2% choose the first and second, if 3% choose first, second, and third, that will be the project. Okay, I think that should be all. However, we need to for next class, I think we need 1 hour. I need to go through the project to how going to run the project because I think there is no more lecture. Okay, I'm going to map the what call it the I want to see there's a you have done the the basic schematic drawing of gear. After that, are you going to do the gear system with interaction process. Then it can go for the shaft. Then you are the bearing because the shaft you can have the bearing. Then you replace the first gear with that's it. Okay, I want to map everything. We're going to discuss the project. If you proceed with project, you can ask any question on project. Will be on next class. Will be on Tuesday 8 p.m. Okay. Okay, I think we're going to end the lecture today. Any more questions before we end? Okay, we need to discuss the project and how we're going to run the project. Because the minor project I think done the other one. Okay, that will be independent study. The bolt, the belt, I will give you the bolt and belt. All right, that's the bolt, that's the belt. The bolt and welding. So the bolt and welding are the videos, and you can proceed with that one. I want to summarize everything. Okay, to see that because there is no more lectures. Okay, after this, no more lectures. Just up to you to run the project. Want to see, except for they have another test 2, maybe on the week 14 or week 15, depend on situation. But the schedule going to be week 15. There's test 2, you have major project, you have minor project. Major project is independent. We're going to discuss the whole thing, major and minor, as well as the. I think we discuss the major. It will solve the test 2 as well. Where to submit and so on. That will be on Tuesday, 8 a.m. Okay, right. Any more questions before we end the lecture? All right. Since there's no more question, I will share you the QR code for attendance. And thank you very much. Assalamualaikum.